No, it's okay. I'm sure I will at some point. All right, guys, so let's look at number 1 together. So again, when you're multiplying like this, you can write it as 2 separate logs like this that have been added together. So we could do log base 5 of 25 plus log base 5 of a. And then could you simplify either of those logs? Yeah, what is log base 5 of 25? 2. That is your answer. So you guys try number 2. All right, guys, first step, did you do log of 10 plus log of b? And what is log of 10? 1. 1 plus the log of b is your answer. Yes? Easy? Okay. Step 1, easy. Baby steps, okay? All right, so next one is division. Remember with exponents, when you divide, you subtract. Same thing with logs. It's very exciting. Exercises. Thank you so much. All right, guys, so let's do number 3 together. So this is going to be rewritten as log base 3 of 9 minus log base 3 of 2. And what is log base 3 of 9? 2. So you have 2 minus log base 3 of 2, and that's it. Okay. You guys try number 4. Walking around, it looked like most of you got there. Starts out as natural log of 4 minus natural log of e. And what is the natural log of e? 1. It's one you definitely need to know, okay? All right, still good? All right, then we have exponents. So when you add a power to a power with your exponents, you multiply. And so now you're multiplying. Your exponent becomes your coefficient. All right, guys, number 5 is going to be 6 log base 2 of 4. So what is log base 2 of 4? So this is really 6 times 2. So 12 is your answer. Okay? Did you guys do 6 already? Yeah. 5 log base 3 of 27. That's like 5 times 3. Did you get 15? Yeah.
So can you always multiply the base by the
No, it just happened to work out in this case. Let me give you one that isn't. Let's do... Okay, so that'd be like 5 log base 2 of 8, 5 times 3. That's what you're asking me. Okay. All right, so we're okay with that rule? Don't get scared. All right, guys, so we're going to use our properties and rewrite it as the sum and difference of logs. Sometimes this is called expand. So I'll give you a second to jot these down. We'll go through them together. Guys, you ready? Okay, so first in number 7, I see that we have division, right? What does division mean? Okay, so this is really the natural log of x squared minus the natural log of x plus 4. And go ahead and put that in parentheses so you don't just have this random 4 floating around out there. And then we should simplify as much as we can. So that x squared, can we do something with that too? Yeah, where can that go? So 2 natural log of x. Can I break apart this x and the 4? No. The only things you can separate are multiplication and division. You can turn those into addition and subtraction, but you can't separate addition or subtraction. So it's just minus natural log of x plus 4, and you are done. Okay. All right, you guys try 8. It's a little trickier. The only part about these that gets tricky is like what's actually positive and negative, where do the signs go? Let's see how you did. So guys, your final answer, I would take 2 natural log of x minus 4, and then minus natural log of x minus 2 natural log of x plus 3. How many of you guys have plus here instead of minus? Yes? Okay,
Well, is there any, like, is there some things you do for others, like, in the first step, you need the 2 to the front first?
So you just have to be careful, make sure, like, it can't go in front of this, because all of these are not squared. If you're separating it out, like if you're doing this in one step, that's fine. But if you put, like if you rewrote it as 2 natural log of, that's not the same as what's originally given, because this means all of this is squared, which is not the same. Are you with me or no? Okay. All right, guys, the addition subtraction step. Look at what I did on the first step. See how I used parentheses here? I did that because isn't all of this in the denominator? Okay. I know these two are multiplied together, so that's plus, but they're all in the denominator. So if you were to distribute your negative, this would be minus, and this would be minus. So when you're doing these, anything that's in the denominator should have a negative in front of it. It's like it has a negative exponent. It got moved to the denominator, okay? Anything that's in the numerator should be positive. So let's squeeze in one more of these just to make sure you've got it. Let's do natural log of x plus 2 times x over x, don't write what I just wrote, x plus 1 cubed times x minus 5. Do that. So same thing here, you're expanding. Guys, this one, are we ready or sorry? You should have natural log of x plus 2 plus natural log of x minus 3 natural log of x plus 1 minus natural log of x minus 5. Would you okay with that? Yes? You guys went from so lively to so... You ran out of steam. All right, let's try again. So now you're going in reverse. write as a single logarithm. Sometimes that's called condensed. Remember, am I on 9 and 10, I think? Or am I on 10 and 11?
That one. The extra one was 9.
Oh, I think I labeled it 8.5, but
Oh, yeah.
whatever.
Yeah, with that.
Number wherever you are, it's fine. So we are now starting with these expanded logs, and we're going to turn it back into just one log, like what we started with in those last problems. I'll do the first one with you. I just want to give you time to break. All right, guys, I'm going to do this in a couple of steps. You'll probably get to the point where you don't need to do it in very many steps, but when we first start, let's make sure we understand everything that's happening. Do you guys agree with log of x to the 6th? Putting that exponent back there, and then minus log of y to the 3rd. Okay, now here's the tricky part on this one. I need to write 4 as a log. Okay? So we are thinking like off to the side here. The others are log base 10, right? So log base 10 of something has to equal 4. What is that something going to be? We'll do it this way. Wouldn't it be 10 to the 4th equals what I'm looking for? 10,000? Okay, so this is plus log of 10,000. And you guys know that like 10 to whatever exponent, that's how many zeros it has? Did you not know this? Okay, some of you know, so if I have 10 to the 6th, I just do a 1 and then I go 1, 2, 3, 4, 5, 6, okay, that's what that is.
Learn something new today.
Yeah, all the little things.
So,
You don't trust me? Think about it, 10 to the 1st, right? That is 1 0, 10 squared. 2 zeros, yeah, you with me?
It's working.
There's a pattern. Yes, I promise you it's true. Almost. Yeah, let's not. There's a lot of zeros. All right, guys, so we still need to continue condensing. So
that is you condensing continue.
we're condensing. Something. So this, I've got a log, then I have a minus, then I have a plus. What does a minus mean? Divide. What does a plus mean? Multiply. So these are easy. It's going to be x to the 6 over y cubed. But where does the 10,000 go? Numerator or denominator? Numerator. It's not negative in front of it, right? Okay, so it goes in the numerator. So this is really log of x to the 6th times 10,000 over y cubed. That is your final answer. If you're confused by that, think about if I had rewritten it. What if it had said 6 log of x plus 4 minus 3 log of y? Would you have doubted at all then that the 10,000 should have been in the numerator? No. Okay, so it's the same thing. All right, you guys try 10. Do you have any left? I want to go over it here because I don't think you're alone in what you're doing there. Guys, a couple things I've seen. It's weird walking around. You guys are great with the exponent. Right? Everybody's fine with this stuff. Correct? Okay. So then, when you're condensing this, you are writing it as a single logarithm. I saw some of this. I saw a to the 5th times a plus 1 to the 8th. And then I saw people divide the whole thing by another natural log. No. Okay, that is not what's happening. Yes, there is division, but that's not where it is. A to the 5th, times a plus 1 to the 8th. That is over b times c cubed. Okay? That's
By saying b times c cubed, that shouldn't be saying they're multiplied together or added together, but saying it's maybe not.
Okay, so think, if it's throwing you off, think about it this way. What if I wrote this little section minus natural log of b plus natural log of c cubed? Same thing, right? So you are multiplying them. They're both in the denominator, though. All right, we okay there? I just want to check something.
Oh my god, are you doing
No. No, you're not doing trick quiz, don't worry.
Sorry, that's the class.
That would be terrible.
I would literally be so mean.
I know you do. I saw you. You could just not be here. All right, guys, jot down the directions here. I want to go through 9 with you because these are very different than anything we've seen so far. So natural log of 4 is equal to a, natural log of 5 is equal to b. We're close, guys. We have this in one more slide, and they're the easy stuff.
Oh, really?
Yeah, you can make it, guys. We'll get through. I'm seeing some people who are telling me, nope, not. We're not what?
I don't think I'm on number 9.
Yeah, you shouldn't be on 9. What are we on, like 11? Yeah. It's like I just didn't number 2 of them and then started over with 9. So, yep. Yeah, that's what happens. Was a good facial expression. Alright guys, are you ready?
Yes.
Alright, so our only options are natural log of 4 and natural log of 5. So you need to figure out how to make a 20 out of 4s and 5s, and your only options are multiplying, dividing, or exponents. So you can only use the things that we've done the properties of, okay? So how can I make 20 out of a 4 and a 5? Woo! All right, 4 times 5. So this is really natural log of 4 times 5, right? How can I expand that? Not everyone at once, guys. Okay. Yes, so natural log of 4 plus natural log of 5, right? Well, and natural log of 4 equals A, natural log of 5 equals B, so this is A plus B. You do not put those letters, the A's and B's in until your very last step, okay? All right, so you guys try 10, 11, and 12. Only using 4s and 5s. You can do it. Take a second, try those 3, talk to someone around you, see if you're getting the same thing, and then we'll look at them. 10 and 11 aren't too bad, 12's a little weird. You just have to think. I know, that's asking a lot. Why is what? Okay, because it's not the natural log of 4 divided by the natural log of 5. Yes. Sometimes you don't. It's really helpful, I know.
Do we have to use 4 number 11?
I don't know how you're going to get 100 out of not using the 4.
We got it.
Okay.
Divide by ln 5 to the second.
But that's just ln of 5.
But no, wait, isn't it 5 to the third one not 5?
Yeah.
And then minus 25, right? Can't do that.
No.
Why not?
So it's not, okay, so the division rule you're talking about.
Yeah.
If it's ln of like 5 divided by 2, that is what you're talking about.
Oh, I guess I see what you're saying.
See how they both have ln?
Yeah. Okay.
Alright.
Alright.
Use the 4.
I would feel like such a genius right there.
Alright guys, let's look at them. Alright, so 10. Do you guys agree that that's really ln of 4, natural log of 4 minus natural log of 5?
Yes.
So A minus B? Okay, good. Yeah? Alright, now how are we making 100 in very creative ways? How do we get 100 out of 4s and 5s?
L and 5 plus L and 5 minus L and
Minus? There should be no divide.
plus.
Yeah, because isn't this 5 times 5 times 4? Yeah, or you could have done 5 squared times 4. Totally fine. So ln of 5 plus ln of 5, natural log of 5, natural log of 5 plus natural log of 4. So A plus, oh I'm sorry, B plus A. I mixed up my letters. So that's really 2B plus A. If you had done the exponent way, you would have had 2 times natural log of 5. It would have been 2B plus A.
So you wouldn't take that to the A also?
No, so let's do it. Let me just write it. So if you had done 5 squared times 4, right? Natural log of 5 squared plus natural log of 4. See how the 2 would only go with the 5? Okay. So that would have been 2 times B plus A. So a different way to get there. right, guys, how'd you do on 12? All right, when it's a decimal, think of it as a fraction. What is 0.25 as a fraction? 1/4, right? Let me go through 2 ways to do this. You could think of that's natural log of 1 minus the natural log of 4. What is the natural log of 1? We did it in your warm-up. 0. So this is really like 0 minus a, which is just negative a. Or you could have done natural log of 1/4 is like natural log of 4 to the negative 1, which is negative 1 times natural log of 4, which is negative a. So either way, you get to negative a. So both of those ways are fine. What? Yes, because but your final answer, simplified answer, is still just negative a. Sure. Yeah, yep. All right, one last thing, guys. Change of base formula. Guys, this is literally the easiest thing you will do all year. Not kidding.
I'm kidding.
Not kidding. Is what I'm
I'm
saying.
kidding. Oh, I thought you said that.
That would have been so mean. I'm kidding. It's the hardest thing you'll do all year. No, it really is easy. So, jot it down, and then I'll show you the first one. Okay, when we're doing the change of base formula, this is an easy way to enter it into your calculator if you are going to have a calculator, or I might just ask you, how would you write this with a change of base? All you do, the base, I say, goes in the basement, like whatever the base is always the denominator, and then whatever you're taking the log out is here. You can do it with logs, you can do it with natural logs, it does not matter. I usually write it with natural logs because it's fewer letters. Like, that's literally the only reason. It's just faster. So log base 4 of 73. That is, either way, the log of 73 over the log of 4, or the natural log of 73 over the natural log of 4. And that is it.
That is the easiest thing I've ever done.
I told you, it's pretty darn simple. So what's 14 going to be?
Log 42 over log 6.
There you go. So guys, what you're doing with this is just turning it into a common log or a natural log when it was something else to begin with. Right, easy? Okay. It's homework.